Hello Wildcats, welcome to your geometry class. So today we're going to discuss about two more um, congruence criteria for a triangle. So in this video, you will be going to determine congruent triangles by comparing two angles and one side. So we will be proving and applying ASA theorem and also AAS. As what I've told you guys, we'll be dealing with two angles and one side. The only difference is that for the first one, ASA, the side is included, and the other one, AAS, is side is not included. Okay, so in this video, I'm going to explain also how are you going to identify if the side is included or not included. All right. So the first example is that why is a triangle ABC is congruent to triangle DEF. So basically, one of the most important thing, one of the skills that you need to learn about identifying triangles are congruent is identifying the corresponding parts of the triangle. So the question there is, are the corresponding parts are congruent? So in this criteria, you only need to have two angles and one side to be congruent, so that you could tell that the two triangles are congruent. Now, let's take a look at triangle ABC and let us examine and compare that to the corresponding parts of this triangle to your triangle DEF. Your triangle C, or your angle C corresponds to angle F, and we could tell that they are corresponding parts, which is the angle. It is because of this symbol here. So if you see that symbol, meaning they are congruent, so you have angle C is congruent to angle F. Another one is this angle here, angle A corresponds to angle D. So you have angle D is congruent to angle A. So maybe I can just exchange that. Angle A is congruent to angle D. Now the question there is that yes, they have the same criteria, like you have two angles and one side. Now the examine there is that is it included side or is it not included side. So in this example, why they are congruent, it's because your segment, okay, this segment here, segment AC, okay, segment AC is congruent to segment FD, which is also they are corresponding side. Okay, segment AC is congruent to segment FD or DF, segment DF. Okay, now the question there is that is the side included or is the side not included, so that you have to choose, is it ASA or AAS. Now the difference now between these two is that if the side is in between the two angles, okay, of the two angles that are congruent, and this is our example here, angle A and angle C shares a common side. Same with FD, okay? D and F, angle D and F, share a common side. Therefore, we could say that this one is at the middle. So, segment AC is congruent to segment DF. Thus, okay, thus, the triangle ABC is congruent to triangle DEF by ASA, or angle side angle. Okay, so it's the same. The only difference is that one of the side can be included or not included. I'll give you one example of AAS. So let us say I have here a triangle, two triangles, M, N, and O. Then another triangle here, X, Y, Z. So let us say N is congruent to angle Y, and M is congruent to angle X. Now, the included angle here is this one. Included side, sorry. The included side is here. Now, those sides that are not included, it's either your YZ, or okay, or it can be your MO. So look at the difference now. So the symbol here, it's in between the two angles, but in here it's just only one angle that has that side of it. Okay, so that is an example of ASA and AAS. Again, ASA, it must be, the side must be included, meaning the two angles share a common side. And then your AAS, side is not included, meaning it's just only one angle has that side, that included side there. Now let's have some application here before we go to the concept. A technician installs cables from a cell phone tower to the ground. To pass inspection, both cable must be the same length. Thus, this installation meet the cable length requirement. So we have to explain. So what are we going to do here is that the ground tower and the cables from two triangles, which is triangle ABX and triangle CBX. So these two triangles now has common, okay, they have common side. All right angles are congruent, so your angle AXB, okay, your angle AXB is congruent now to CXB, angle CXB. Mr. Why is it congruent? It's because all right angles are congruent. All right angles are congruent. Okay, I'm going to use symbol. So you have to practice reading the symbols that I'm using. Okay, by reflexive property of congruence, your BX is also congruent to BX. So this side here, okay, so BX, segment BX, is congruent to segment BX. Okay, we'll be using reflexive. Okay, next is you have your triangle AXB. Yeah, it's given here. Triangle or angle, sorry, AXB or ABX, sorry, is congruent to angle CBX. Okay, this is given. Okay, and that given give us a measure of 52 degrees. Okay, so we could now say that, okay, I'll just number that. Okay, number 4, I'll just put it here, sorry guys. Number 4, we could now say that your triangle ABX, okay, is congruent to triangle CBX. Okay, what is the reason for this one? It's because of A angle side angle. So ASA. So the angle, it's this one. Okay, this angle. Okay, Okay, just use maybe blue. The angle here is congruent to that angle. This angle is congruent here. And again, it's an included side, which is in between. They have common side of the angle given. So the BX is an included side. Now, on number 5, because we are looking for the cable length to meet the inspection requirements. Therefore, your AB, okay, AB is congruent now to CB. So this here we are the main purpose why we are checking is that these two cable must be congruent. Okay, so on number 5 I'll be using blue here. Your AB, okay, to pass this inspection, AB must be congruent now to BC. The question is, do we have enough justification, or do we have enough evidence why does the cable AB is congruent to BC? It is because of CPCTC, which is congruent part of congruent triangle is congruent. Okay, because you have already proven that these two triangles are congruent by virtue of ASA. Therefore, every single parts of this congruent triangle must also be congruent. All right, so let's proceed with the concept summary of this triangle congruence. In your theorem 4.6, the angle side angle, if triangle MNL and triangle RTS, okay, if MN is congruent to ST there, and angle M is congruent to angle S, and angle N is congruent to angle N, then the two triangles are congruent. Now remember, your ASA, the side must be included. For the other theorem, which is AAS theorem, or angle side, one of the side that is involved there is not included side. All right, so if you have any question, guys, feel free to contact me, feel free to email me, feel free to call me. Okay, um just be safe always, and I'm always here for you guys. We can do this. Bye bye.